Good afternoon, everyone. Today we're going to be looking at the area of composite shapes. So this is the grade 7 curriculum. We just finished covering the area of circles, rectangles, parallelograms, triangles, all separately. So now we're going to try to put things all together, okay? So here is the shape that we're going to be calculating the area for today. And I'm going to remind you guys, before we begin, that the area of a rectangle is the length times the width. So length times the width. And this little guy is a fraction of a circle, and the area of a circle is pi times the radius squared, pi r squared, okay? So first things first, we notice that the 8 centimeters above must coincide with the length at the bottom as well, meaning that this length here must also be 8 centimeters long, okay? Now, this shape, this circular shape at the bottom of the rectangle is exactly half of a circle. This kind of looks like a Pokeball for you Pokemon enthusiasts out there. And so what we want, ultimately, is the area of this part, which is 1/2 of a circle, okay? So if we want, we can write that the area of half a circle will simply be the area of a full circle divided by 2, 1/2. And so we'll have pi r squared divided by 2, okay, or 1/2. Now, the first part, let's call this area 1, will be the area of a rectangle, which is length times width. And let's call this bottom half circle area 2, which will be the area of a half circle. Now, the total area, let's say area subscript total, will simply be the sum of area 1 and area 2. And so we can write that A total is equal to A1 plus A2. I put a big emphasis on organizing and structuring our solutions in class. I really want students to get in the habit of organizing their solutions so that they're easy to follow before things get too complicated. And so now we can start filling in our equations. A1 is the area of a rectangle, and so we have length times width, plus A2, which will be pi r squared over 2. Okay? Again, I really like getting students to fill in their formulas with the variables intact before plugging in the values, okay, for establishing habits. And so now, the length of the rectangle is 8 centimeters, while the width is a full 12 centimeters. And the radius of the circle we have not exactly pinpointed yet. We're given the distance across the circle being 8 centimeters. However, if you think back to the dimensions of a circle, this is its diameter, the length across that travels through the center. And so, if its diameter is 8 centimeters, remember at the beginning of the unit, the radius, the distance from the center to the edge, is exactly 1/2 of the diameter. The radius is equal to the diameter divided by 2, or 1/2 of the diameter. And so the radius will be 8 centimeters divided by 2, and so the radius is thus 4 centimeters. And this is the value we're going to use for r in here. And so now, the length times the width will be 8 times 12, plus, and now we'll have pi times r, which is 4. So pi times 4 squared. I always plug in the values by putting them into brackets. That just lets me know that I'm plugging the value of a variable inside of an expression, right? So pi times r4 squared divided by 2, okay? We can make the bracket a bit tighter like that. And now we can start calculating. So following order of operations, bed mass, as you guys all know, 8 times 12 starts us off with 96. 96 is thus the area of the rectangle, A1. Next, we have pi times 4 squared, all divided by 2. And so, you guys can do that on your calculator. If you do it with the pi button itself, you'll get a decimal number of 25.13, okay? this will be the area of that half circle. And putting them together, A1 plus A2 for the total area, we find that the total area, let me use the French here, total area will be 96 plus 25.13 for a total area of 121.13. And now to finish off our solution, we will add in the units at the very end. The lengths of our shape were in centimeters, and area is a two-dimensional measure. And so our units will be squared centimeters. The 2 in the exponent for two-dimensional, so we'll have squared centimeters as our unit of measure. And so our total surface area, our total area of the shape is 121.13 squared centimeters, okay? So I hope this helps. I hope this starts the idea of putting shapes together. As we know in the real world, we have tons of different shapes, so it's nice to put things together. Again, huge emphasis on writing out nice, structured, organized solutions. Units always added in at the end to make sure we don't leave those out. Building good habits for future science classes coming up. So if you have any questions, comments, anything specific relating to this topic that you'd like to see kind of explained further, please leave comments and have a great day.